So this is double angle formulas, sum, difference formulas part 2. So here I will be going over the double angle formulas. Again, those are really just being derived from the sum and difference formulas. So going over the first one, we have sine of 2x, right? Sine of 2x. That is equal to 2 times sine of x times cosine of x. Then we have cosine of 2x. Cosine of 2x is equal to cosine square of x minus sine square of x. And so looking at this, if you recall, sine of any angle, right? So let's just say sine of x plus v, right? Or x plus y. Again, with practice, this will become easier, but really we know that this is just sine x, right? Sine x, then we have cosine y, switch the angle, so now we have plus cosine x, and then sine y. So now if we have same angles, right? Sine x, this would be cosine x, and this would be sine x. And really think about this, this is just sine x cosine x, right? Because it doesn't really matter whether you have a times b or b times a, right? So this is just 2 sine x cosine x. So that's how the first one was derived. And same thing for the second one. We know that cosine of x plus y here, right? That is cosine x, cosine of y, right? Cosine of y, and then we have minus, again, it's the opposite sign, minus sine x and sine y here, right? And so if we think about it, and if there's no y here, if it's just x, then obviously this becomes x, and this becomes x, right? And so cosine x times cosine x is just cosine square x. Sine x times sine x is just sine square x. And so we get this thing over here, cosine square x minus sine square x, that's what we have here. So that's just how you can derive it, knowing those sum and difference formulas. So that's the way how you derive it. But however, you will see that when you are trying to solve trigonometric equations, trying to prove one side is equal to the other, it's important to understand that you can write this into other ways which are important to understand. So cosine square x, if you recall, first of all, the Pythagorean trigonometric identity that cosine square x plus sine square x is equal to 1, you should understand, you can derive that 2 cosine square x minus 1 is equal to this, which is equal to 1 minus 2 sine square x. And all I really did was cosine square x is 1 minus sine square x. 1 minus sine square x minus sine square x is 1 minus 2 sine square x, right? And similarly, if you write sine square x as 1 minus cosine square x, you have cosine square x minus 1 minus cosine square x, right? And so solving this, you see that it's minus 1 plus cosine square x, so we have 2 cosine square x, and we have minus 1, and that's where we got this from. So really, we can write cosine square x minus sine square x as 2 cosine square x minus 1, also 1 minus 2 sine square x. So that's how we can write this. And obviously sine of 2x is just 2 sine x times cosine x. So those are the key double angle formulas. And obviously I will just go over the tangent one quickly. So the one for tangent, right, if you have something like a tangent of 2x, that is equal to, again, if you recall, the sum or difference formula for tangent, you have something like tangent of x plus y, right? It's tangent of x, and you take plus tangent of y, and you take the opposite sign here, you have the 1, you do minus tangent x, right, times tangent y. So here you're adding, here you're multiplying, and you need the minus sign because you have the addition sign here. And so doing tangent of 2x, we see that's tangent of x plus tangent of x. Well, that's just 2 times tangent of x divided by 1 minus tangent of x times tangent of x. That's just 1 minus tangent square x. So tangent of 2x is equal to 2 times tangent x, all divided by 1 minus tangent square x. So those are the double angle formulas that you should familiarize yourself with. And so that's another big thing. Now I can go over one sample problem here, when you may want to use it or how it can make it easier. Again, but this is just an example. So for instance, you have something like sine of 45 degrees, right? Sine of 45 degrees plus 60 degrees. You have something like that. Now if you want to find this, you could just do sine of 105 degrees, right? You can just do sine of 105 degrees. However, at times what happens is you may have a sum that's really giving you some weird number for which we do not exactly know what the reference angle is, or we have not memorized that specific reference angle on the unit circle, right? It may not be pi over 6, pi over 3, or pi over 4. It may be some weird radian that we really haven't found a ratio for. So that could be a problem. That's why if you know the formula, you can just find it in terms of 45 degrees and 60 degrees, for which we do know the ratios, right? Because this is just pi over 4, this is just pi over 3, right? But still, here I think this one is easy to understand, because we have this is 90 degrees, right? So looking at this, this would be somewhere here. So our reference angle would be 75 degrees. Now, looking at this, right, we know that this angle is obviously in quadrant number 2. So sine of 105 degrees, right? Sine of 105 degrees is really just sine of 75 degrees. And both of them have positive values, because this is in the it's second quadrant, obviously, for which sine of that angle is positive, similar to sine of the reference angle, right, which is obviously positive because it's in the first quadrant. So these values, right, are equivalent. However, we really do not know what sine of 75 degrees is. That's why I was saying that this formula is really useful, because we do not know what sine of 75 degrees is, because 75 degrees is not something on the unit circle that we have memorized, right? However, we do know 45 degrees and 60 degrees. But whatever value we get is equivalent to sine of 75 degrees. You can check that on your calculator. But using the formula, right, we know that this is sine of 45 degrees, right? Sine of 45 degrees times by cosine of 60 degrees plus cosine of 45 degrees times sine of 60 degrees. And so sine of 45 degrees is root 2 over 2. Cosine of 60 degrees is 1/2. Plus cosine of 45 degrees is root 2 over 2 times sine of 60 degrees is root 3 over 2. Again, that's just off the unit circle. And so solving this, we get root 2 over 4 plus root 6 over 4. And so we can add this and we get root 2 plus root 6 all divided by 4, because that's just common denominator, right? So if you evaluate this, or you evaluate sine of 75 degrees, right, that should equal sine of 75 degrees. However, we have not memorized this value, so our final answer would just be that. And so we have used the sum and difference formula for sine to evaluate sine of 105 degrees. So if you're given a question like evaluate sine of 105 degrees, well, think about angles that you can split 105 degrees into. And you can split 105 degrees into 45 and 60, and then further evaluate using this formula, and you will see that your answer is root 2 plus root 6 all divided by 4. So thanks for watching.